Earth's history is a tapestry woven with moments of unimaginable upheaval, cataclysms that have shaped the very fabric of life. Among these, one event stands as a monument to destruction and transformation, a single day that would echo through the ages. 66 million years ago, the world was ruled by giants. Towering forests stretched across continents, and the bones of ancient creatures lay buried beneath layers of stone, silent witnesses to the passage of eons. In the late Cretaceous, the air was thick with the scent of ancient flora and the land teemed with life. But on one fateful day, a darkness began to creep across the horizon, casting a pall over the vibrant world below. From the silent reaches of space, an asteroid, 10 kilometers wide and ancient beyond comprehension, raced toward Earth, its surface scarred by eons of cosmic collisions. This celestial missile carried a force greater than the combined fury of every volcano and earthquake in Earth's history, a power capable of reshaping continents in a single heartbeat. Its target was a tranquil, shallow sea where the Yucatan Peninsula now lies, a place teeming with marine life, coral reefs, and delicate ecosystems, all unaware of the doom descending from above. In an instant, the asteroid struck, unleashing a blast so violent it vaporized rock, sea, and sky. The explosion sent a column of superheated material arcing into the upper atmosphere, a beacon of destruction visible across the globe. The immediate aftermath was apocalyptic. The land near the impact was reduced to molten chaos, a landscape of fire and ash where nothing could survive. The force of the collision carved a crater 180 kilometers wide and 20 kilometers deep, a wound in the planet's crust that would never fully heal. Shockwaves tore through the crust, triggering earthquakes of unimaginable magnitude. The ground heaved and split, ancient forests collapsing as the very earth convulsed. Across continents, landscapes were transformed in moments. Mountains crumbled, rivers changed course, and entire ecosystems were swept away by the violence. The impact displaced unimaginable volumes of water, spawning mega-tsunamis that towered hundreds of meters high. These waves raced across ancient oceans, obliterating coastlines and sweeping away everything in their path, from coral reefs to primeval forests. As the world reeled from quakes and floods, the sky itself became a weapon. Superheated debris rained down, igniting the air and setting the world ablaze. Trillions of tons of pulverized rock and dust were hurled into the stratosphere, forming a shroud that blotted out the sun and plunged the world into darkness. As this material fell back to Earth, it superheated the atmosphere, turning the sky into a furnace. The air shimmered with heat, and the ground below was scorched anew. Wildfires erupted on a scale never before seen, leaping from forest to forest, consuming entire continents in a relentless inferno. The land was transformed into a sea of flames, the air thick with smoke and ash. Where once there had been lush forests, now only smouldering ruins remained. The sky glowed a deep, unnatural red, filled with drifting embers and the memory of a world lost to fire. For the creatures of this world there was no refuge. The relentless advance of fire and ash left no sanctuary untouched, and the struggle for survival became ever more desperate. The blast zone itself was a wasteland, scorched, lifeless, and unrecognizable. But even far from the crater, the searing heat and choking air claimed countless lives, extinguishing entire populations in moments. The atmosphere became a suffocating blanket of soot and ash. Daylight faded to twilight, and the world was plunged into a choking gloom that stifled life and hope alike. The once thriving ecosystems, home to creatures great and small, were thrown into chaos. The age of the dinosaurs, which had flourished for over 150 million years, was brought to the brink of annihilation. The day the sky fell marked not only the end of an era, but the beginning of a long, cold night. Under a shroud of dust and darkness, life on Earth faced its greatest test, a world in flames, struggling to survive in the aftermath of cosmic catastrophe. When the infernos finally died down, the world was left in a state of utter devastation. The surface of the earth, once vibrant and teeming with life, was now a scarred wasteland, blanketed in ash and the remnants of ancient forests reduced to charcoal. Above this ruined landscape, a suffocating shroud of dust, soot, and vaporized sulfur, trillions of tons of it, rose high into the stratosphere. This dense, toxic veil was so thick that it blotted out the sun, transforming day into a perpetual twilight. The world was plunged into an impact winter. For years, perhaps more than a decade, the planet endured a relentless chill. Snow and ice crept across continents, burying the land beneath a silent, suffocating blanket. The air itself grew thin and biting, filled with the acrid tang of chemicals and the ever-present threat of acid precipitation. Sunlight, the engine of life, was all but extinguished. The surface received only a faint, ghostly glow, barely enough to cast a shadow. Photosynthesis ground to a halt, and the energy that once fueled entire ecosystems vanished almost overnight. Temperatures plummeted by as much as 25 degrees Celsius. Rivers froze solid, lakes became sheets of ice, and even the ocean's surfaces glazed over in places, reflecting the dim, colorless sky above. The darkness and cold proved fatal for the planet's food chains. Plants that had survived the initial firestorm now succumbed to the lack of light and warmth, their leaves shriveling, their roots freezing in the permafrost. Forests became graveyards of frost-bitten trunks and fallen branches. The last green faded from the world, replaced by a palette of greys, whites, and the deep black of charred wood. The great plant-eaters, once the dominant force on land, found nothing to sustain them. Their massive bodies, built for abundance, could not survive the famine. Within months their numbers dwindled, leaving only silent skeletons as evidence of their passing. The predators that depended on them, like the formidable Tyrannosaurus rex, soon followed. With no prey to hunt, they too fell victim to starvation. Their reign ended not by battle, but by the slow, inescapable grip of hunger. The oceans, once a sanctuary of life, mirrored the devastation on land. The surface waters grew cold and dark, and the vibrant colors of coral reefs and kelp forests faded into obscurity. Without sunlight, phytoplankton, the foundation of the marine food web, perished en masse. The water columns, once alive with microscopic activity, became empty voids, devoid of sustenance for higher life forms. The collapse was swift and merciless. Each level of the food chain, from tiny zooplankton to massive marine reptiles, was swept away in a cascade of extinction. The very air was transformed. The atmosphere, saturated with foreign chemicals, became a cauldron of reactions. Ozone thinned and the balance of gases shifted, further destabilizing the climate. The unique geology of the impact site unleashed vast amounts of sulfur, which mingled with water vapor to create a global haze of sulfuric acid droplets. This toxic mixture returned to the surface as acid rain, corroding rocks, leaching nutrients from soils, and poisoning what little life remained. For years the land was scoured by these relentless, caustic showers. The oceans, too, became hostile. Acidification dissolved the shells and skeletons of countless marine organisms, from tiny plankton to the intricate spirals of ammonites. Coral reefs, once bustling metropolises of marine life, crumbled into lifeless rubble. Ammonites and other shelled creatures vanished, their remains settling into the sediment as silent witnesses to the catastrophe. The seafloor, once alive with color and movement, became a graveyard. The silence of extinction echoed through the water, broken only by the slow drift of silt and the collapse of ancient reefs. The world was beset on all sides. Darkness, freezing cold, starvation, and acid rain. It was a crucible of extremes, a relentless gauntlet that tested the very limits of endurance. In the end, the toll was almost unimaginable. 75% of all species, plants, animals, and microorganisms, were erased from existence, their evolutionary stories cut short in a geological instant. The non-avian dinosaurs, once the undisputed rulers of the land, vanished utterly. Their nesting grounds, once filled with life, became silent fields of stone and bone. The great marine reptiles and the soaring pterosaurs, too, disappeared forever, their bones left to weather in the empty places of the world. This was extinction on a scale never before seen, a reset of life's clock, a clearing of the evolutionary slate. The world was left empty, waiting for new beginnings. Yet even in this age of death and darkness, life endured. Hidden in burrows beneath the ash and ice, small, tenacious survivors clung to existence, waiting against all odds for the return of the sun. As the last remnants of the catastrophic impact faded and the sun's rays finally broke through the thick, lingering haze, a new era began to unfold across the battered Earth. The world that emerged was almost unrecognizable, a planet transformed by devastation, yet brimming with the raw potential of rebirth. The land bore the scars of disaster, forests reduced to blackened skeletons, rivers choked with debris, and a silence where once the thunder of dinosaurs had echoed. But life, ever resilient, began to reclaim the wastelands, with shoots of green piercing the ashen soil and the first tendrils of jungle creeping back across the continents. The long, frigid darkness of the impact winter gave way to a world gripped by a relentless greenhouse climate. Vast plumes of carbon dioxide, released by the infernos that swept the globe, trapped heat and moisture, transforming the planet into a sweltering hothouse. Temperatures soared, especially near the equator, where humidity thickened the air and rainforests flourished in the oppressive heat. The world's climate was now a crucible, forging new forms of life in its relentless embrace. The mighty dinosaurs, once rulers of every land, had vanished, leaving behind empty plains and silent nesting grounds. Their absence created a vast ecological void, a stage set for new giants to emerge. In this altered world, cold-blooded reptiles found their moment. The relentless heat supercharged their metabolisms, allowing them to grow larger and more formidable than ever before. Deep within the steaming jungles and tangled swamps of what is now South America, evolution gave rise to a true behemoth, one that would dominate the waterways and strike terror into all who shared its domain. Titanoboa, the largest snake ever to exist, slithered through these primeval wetlands. With a body stretching up to 15 meters and weighing over a ton, it was a living relic of the planet's fevered rebirth. Its immense size was not just a marvel, but a necessity. Only in such a hot, energy-rich world could a cold-blooded predator reach such monstrous proportions. Titanoboa's bulk allowed it to dominate the rivers, its presence felt in every shadow and ripple. Basking in the relentless sun, Titanoboa absorbed the heat it needed to power its massive body. Its metabolism thrived, enabling it to hunt, grow, and reproduce on a scale unmatched by any snake before or since. Hidden beneath the surface, Titanoboa was a master of ambush. It waited motionless in the turbid waters, striking with explosive force at prehistoric crocodiles and giant turtles, its jaws capable of crushing bone and shell alike. As the undisputed apex predator of its ecosystem, Titanoboa shaped the very structure of life along the rivers, its reign a testament to evolution's relentless drive to fill every available niche. Yet the rivers were not the only stage for giants. On the isolated continent of South America, a new breed of predator was rising to dominance on land, reshaping the balance of power in the absence of dinosaurs. These were the Forus racids, colossal flightless birds known as terror birds. With keen eyesight and razor-sharp instincts, they stalked the open plains and forest edges, unrivaled in their pursuit of prey. Having survived the extinction that ended the age of dinosaurs, these feathered predators evolved into formidable hunters. Their speed and agility made them the terror of the Paleocene grasslands. Some species stood nearly 3 meters tall, their towering forms casting long shadows over the landscape. Their muscular legs propelled them at astonishing speeds, allowing them to chase down even the swiftest prey with relentless determination. Armed with a massive hooked beak, they delivered bone-shattering blows, dispatching their victims with brutal efficiency. Each strike was a testament to the evolutionary arms race that followed the dinosaurs' demise. For millions of years, these birds reigned as the supreme land predators of South America, their dominance a living echo of the ancient reptilian hunters that came before. This was a time of extraordinary experimentation. With the old order swept away, new creatures evolved to fill every conceivable role: herbivores, scavengers, and predators, each adapting to the challenges of a world in flux. The extinction of the great carnivorous dinosaurs unlocked evolutionary pathways, allowing reptiles and birds to experiment with size and form on a grand scale. For a fleeting epoch, the world belonged not to mammals, but to these titanic snakes and towering birds, apex predators forged by the extremes of a recovering planet. They thrived in the lush, volatile environments of the Paleocene, their reign a vivid chapter in the ongoing saga of life's resilience and adaptability. The age of snakes and terror birds stands as a powerful reminder. Even after the greatest catastrophes, life not only endures but flourishes, evolving into forms both wondrous and fearsome, ready to seize the opportunities of a changed world. As the Earth's climate entered a cooler, drier phase, the planet's surface was reshaped by relentless forces. Glaciers advanced and retreated, carving valleys and leaving behind vast plains. In these ever-changing environments, a new caste of extraordinary creatures began to dominate the land and sea. This was the Cenozoic Era, often called the Age of Mammals, a time when mammals, once small and elusive, rose to become the planet's most prominent inhabitants. Our earliest mammalian ancestors had survived in the shadows of the dinosaurs, their lives spent darting through undergrowth and burrowing beneath the earth, always alert for danger. But with the dinosaurs gone, mammals seized the opportunity to diversify, evolving into a dazzling array of forms and sizes, each adapted to a unique ecological niche. The Pleistocene epoch saw the rise of the megafauna, giant mammals whose sheer size was their greatest defense against predators and the harsh climate. Across the frozen plains of the northern hemisphere, herds of woolly mammoths trudged through deep snow. Their long, shaggy coats insulated them from the bitter cold, while their massive, spiraled tusks were used to sweep aside snow, revealing the tough grasses hidden beneath the ice. These giants were not limited to the Arctic tundra. Some ventured into temperate forests and open woodlands, adapting to a range of environments across continents. In the Americas, the land teemed with other colossal mammals, each uniquely suited to their habitats. Among them was the Megatherium, the giant ground sloth. Towering up to 6 meters tall when rearing on its hind legs, it used its enormous curved claws to strip leaves and branches from the tallest trees, its slow movements belying its immense strength. Sharing the landscape was the Glyptodon, a giant armadillo relative encased in a domed, bony shell. This living fortress weighed up to 1,000 kilograms, its tail ending in a spiked club ready to defend against any threat. Far to the south, in the ancient woodlands of Australia, the Diprotodon, the largest marsupial ever to walk the earth, roamed in herds. This rhinoceros-sized herbivore browsed on tough shrubs and grasses, its powerful jaws grinding fibrous plants with ease. These megabeasts, each a marvel of evolutionary adaptation, became the undisputed rulers of their domains, shaping the ecosystems around them through their sheer presence and appetite. But the drama of gigantism was not limited to the land. In the depths of the world's oceans, a new apex predator emerged, one that would inspire awe and terror in equal measure. As marine ecosystems recovered from past extinctions, they gave rise to Cataclysm's megalodon, the largest shark ever to exist. Its fossilized jaws, large enough to swallow a grown dolphin whole, hint at its dominance. Megalodon was a predator of almost unimaginable proportions, reaching lengths of up to 20 meters, 3 times the size of today's largest great white sharks. Its massive body propelled it through the water with silent, lethal efficiency. Its jaws were lined with rows of serrated teeth, each as large as a human hand, capable of slicing through bone and flesh with ease. A single bite could shatter the skull of a whale, leaving little chance for escape. For millions of years, Megalodon reigned as the ocean's supreme predator, its presence shaping the evolution and behavior of countless marine species. The age of megafauna was a spectacular chapter in Earth's history, a time when land and sea alike were ruled by giants, each a testament to the power and creativity of evolution. From the woolly mammoth's sweeping tusks to the megalodon's crushing jaws, life on Earth had once again embraced the path of gigantism, filling every available niche with creatures of astonishing scale. These remarkable animals were the result of millions of years of evolutionary experimentation, thriving in a world no longer dominated by dinosaurs, but by the relentless drive to adapt and survive. Yet even these titans could not escape the forces of change. Shifting climates and new challenges would eventually bring their reign to a close, ending one of the most extraordinary eras in the history of life on Earth. Our story unfolds in the vast, untamed wilderness of ancient Africa, where the first rays of sunlight sweep across endless grasslands and dense forests. Here, life is a delicate balance, and every dawn brings both opportunity and peril. In this world, survival is dictated by the ever-present threat of predators. The landscape is shaped by the silent movements of leopards, the thunderous charge of lions, and the cunning of hyenas. Every creature, from the smallest insect to the largest mammal, must navigate a web of danger. For millions of years, the dominant story was one of prey and predator. The vulnerable were forced to adapt, developing keen senses and swift reflexes to avoid becoming a meal. The grasslands echoed with the sounds of pursuit and escape, a relentless cycle of life and death. The environment itself became a crucible for innovation. Rivers teemed with hidden dangers, while the forest canopy offered fleeting refuge. The night brought new threats as nocturnal hunters emerged from the shadows, their senses finely tuned to the darkness. In this harsh setting, adaptation was everything. The smallest changes, stronger limbs, sharper eyesight, or the ability to exploit new food sources, could mean the difference between extinction and survival. The land itself bore witness to these subtle shifts, as each species carved out its own niche. Over countless generations, the relentless pressure of predation drove the evolution of new strategies. Some animals developed armor or camouflage, while others relied on speed or the safety of numbers. The ecosystem became a living tapestry of adaptation and counter-adaptation. Vulnerability was a constant companion for the young and the weak. The first moments of life were fraught with danger, and only the most resilient would survive to adulthood. Each new generation faced the same ancient challenges, learning to read the subtle signs of threat in their environment, but the balance began to shift. The appearance of sharp stones and fractured bones hinted at a new force in the ecosystem, one that could alter the rules of survival. The landscape bore silent testimony to the emergence of a creature capable of using the world around it in unprecedented ways. The first deliberate use of stone tools marked a turning point. With these simple implements, it became possible to access new sources of nutrition, marrow hidden within bones, meat clinging to carcasses left by larger predators. The scavenger was becoming something more. The mastery of fire was another revolution. Natural blazes sparked by lightning transformed the landscape, clearing old growth and making way for new life. The warmth and protection offered by fire reshaped the rhythms of the savanna, extending the day and warding off the night's most dangerous hunters. Fire also changed the very nature of food. Cooking unlocked nutrients and made tough meat digestible, providing a surge of energy that fueled further transformation. The ecosystem responded as new opportunities and challenges emerged in the wake of this innovation. The night, once ruled by fear and uncertainty, became a time of activity and possibility. The glow of firelight marked a new presence on the land, one that could shape its surroundings and outwit its rivals. Across the animal kingdom, cooperation and communication offered powerful advantages. But now, a new level of complexity was emerging, one that would eventually allow for the sharing of knowledge, the planning of coordinated action, and the passing of survival strategies across generations. The transition from prey to predator was not a single leap, but a gradual, relentless process. The evidence is written in the land itself, in the marks left by tools, the scars of fire, and the shifting patterns of life and death. Through adaptation, ingenuity, and the harnessing of natural forces, a new kind of animal began to shape the world around it. The age-old balance of power was forever altered, setting the stage for a journey that would reach far beyond the African plains and echo across the globe. To truly grasp the resilience of life, we must travel back billions of years to an Earth unrecognizable from today, a world of churning volcanoes, relentless meteor impacts, and a sky tinted orange by a thick, toxic atmosphere. There were no forests, no animals, not even a blade of grass. Only the raw, elemental forces of nature sculpted the planet's surface. In these hostile conditions, life's first pioneers emerged. For billions of years, the only inhabitants were single-celled organisms, bacteria and archaea, clinging to existence in the deep, mineral-laden waters near hydrothermal vents. These microscopic architects harnessed chemical energy from the Earth itself, thriving in darkness where sunlight could not reach. Over eons, some of these organisms developed the ability to capture sunlight, releasing oxygen as a byproduct. Cyanobacteria formed vast colonies, building layered structures called stromatolites that still exist in remote corners of the world today. Their slow, steady work transformed the atmosphere, setting the stage for more complex life. Then, in a geological instant, life's tempo accelerated. Around 540 million years ago, the Cambrian explosion began, a period when the oceans erupted with an astonishing variety of new forms. In the shadowy depths and sunlit shallows, creatures with shells, spines, and intricate body plans appeared. Some crawled along the seafloor, others floated or swam, each adapting to new ecological niches. The Cambrian seas became a living laboratory, where evolution experimented with countless designs. Among these early animals were the bizarre and the beautiful Opabinia, with its 5 eyes and flexible proboscis, Hallucigenia, a worm-like creature bristling with spines, and Wiwaxia, armored with overlapping scales. Each was a testament to nature's boundless creativity. This evolutionary burst was powered by a dramatic rise in oxygen, which allowed animals to grow larger and develop more complex organs. For the first time, active swimming, burrowing, and predation became possible, forever changing the dynamics of life in the sea. Hard shells offered protection, jointed legs enabled movement across the seafloor, and compound eyes brought the world into sharper focus. These innovations gave rise to the first true predators and prey, setting off an evolutionary arms race that would echo through the ages. The once quiet oceans now teemed with activity. Strange, otherworldly creatures darted, crawled, and hunted, their bodies perfectly adapted to the challenges of their environment. Trilobites, with their segmented armor, scuttled across the mud, while Anomalocaris, an agile alien predator, swept through the water, using its spined limbs to snatch unsuspecting prey. The Cambrian explosion established the blueprints for nearly all animal life that would follow. From these humble beginnings, the animal kingdom's great branches began to diverge, each destined for its own evolutionary journey. As the Cambrian gave way to the Ordovician period, life continued to diversify. New forms flourished in the seas, building the first reefs and filling every available niche. The oceans became home to creatures that would seem utterly alien to us. Graptolites, floating colonies of tiny animals, and nautiloids with their long, straight shells drifting through the ancient waters. The apex predators of this era were not fish, but enormous cephalopods, ancient relatives of today's squid and nautiluses, whose tentacles and keen senses made them formidable hunters. Among them, Camaracaras reigned supreme. Stretching up to 9 meters in length, this giant cephalopod patrolled the ancient seas, its powerful tentacles ensnaring anything that crossed its path. But even these thriving ecosystems were not immune to catastrophe. A sudden and severe ice age gripped the planet, transforming warm, life-filled seas into frigid wastelands. As glaciers advanced and sea levels plummeted, ocean temperatures dropped dramatically. The result was the first of Earth's great mass extinctions, erasing nearly 85% of marine species and leaving the seas eerily silent. Yet, even in the face of such devastation, life endured. A handful of resilient species survived, carrying the torch of evolution into a new era. In the aftermath, the survivors radiated into the Silurian and Devonian periods, giving rise to new wonders. Coral reefs flourished, and armored fish began to dominate the seas. Among the most significant innovations was the evolution of jaws, a powerful adaptation that allowed fish to become the ocean's top predators, forever altering marine ecosystems. With jaws, fish diversified explosively, filling every corner of the ocean and outcompeting many earlier forms. The marine world was now ruled by swift, agile hunters. The Devonian became known as the Age of Fish, dominated by giants like Dunkleosteus, an armored predator as long as a bus, with jaws capable of crushing bone and shell alike. Meanwhile, on land, a quiet revolution was underway. Simple plants crept across barren rock, anchoring themselves with delicate filaments and slowly transforming the landscape. Over millions of years, these pioneers gave rise to the first forests, turning the continents green and setting the stage for the next great chapters in the story of life. As life took root and flourished on land, Earth entered the Carboniferous period, a time when the world was transformed into a realm of towering green giants and extraordinary creatures. Imagine a landscape shrouded in perpetual mist, where immense forests of club mosses, horsetails, and ferns formed dense, tangled canopies. These ancient plants, some reaching over 30 meters tall, created a world both alien and breathtaking. The vast, swampy forests of this era were so productive that they pumped enormous quantities of oxygen into the atmosphere, raising levels to as high as 35%, far above the 21% we breathe today. This oxygen-rich air transformed the very fabric of life. In this supercharged environment, arthropods, the ancestors of modern insects, spiders and millipedes, thrived as never before. The abundance of oxygen allowed their bodies to grow to sizes unimaginable in our present day. Some insects reached lengths of over 1/2 meter, their armored exoskeletons gleaming as they prowled the shadowy undergrowth. Millipedes as long as a car undulated through the leaf litter, while predatory scorpions stalked the damp, mossy ground. This was a world where the smallest creatures became the largest, and the forest floor teemed with life on a scale that defies the imagination. Above, the skies were ruled not by birds, but by meganeura, enormous dragonfly-like insects with wingspans stretching over 70 centimeters. Their delicate wings shimmered as they glided through the humid air, hunting smaller insects with precision. On the ground, the colossal Arthropleura, an immense millipede-like invertebrate, slithered among the roots and fallen logs. Reaching lengths of over 2.5 meters, it was the undisputed giant of the Carboniferous forest floor. These were the largest land invertebrates to ever exist, leaving behind massive trackways that still puzzle scientists today. In the murky waters and along the muddy banks, amphibians flourished. Some grew to the size of crocodiles, their bodies perfectly adapted for both aquatic and terrestrial life, yet their dependence on water for reproduction limited their reach. Then a revolutionary adaptation emerged, the amniotic egg. This self-contained portable pond allowed early reptiles to lay their eggs on dry land, breaking free from the constraints of water and opening new frontiers for life. As the Carboniferous gave way to the Permian period, the world's climate shifted. The lush swamps receded, replaced by vast, arid plains. Here, a new lineage of animals, the synapsids, rose to dominance. These so-called mammal-like reptiles were diverse and adaptable, ranging from agile predators to bulky herbivores. Among them were the ancestors of all mammals, forging a path through the harsh Permian world. The most iconic of these was Dimetrodon, a formidable hunter with a tall, sail-like structure on its back. This sail, rich with blood vessels, likely helped regulate its body temperature in the fluctuating Permian climate. During this era, the continents slowly collided, merging into the supercontinent Pangaea. This colossal landmass stretched from pole to pole, reshaping global weather patterns and isolating vast regions from the sea. The interior of Pangaea became a harsh, arid expanse, battered by extreme temperatures and seasonal droughts. Only the most resilient species could survive in these unforgiving conditions. For millions of years, synapsids and their contemporaries adapted to every challenge, filling every ecological niche across the supercontinent. Their world was one of constant change and innovation. The Permian landscape teemed with life, strange, vibrant, and resilient, from towering conifers to armored herbivores and swift predators. This was a world that had rebounded from past catastrophes and flourished anew. These creatures represented the pinnacle of Paleozoic evolution, each uniquely adapted to their environment, each a testament to the relentless drive of life. Yet beneath the surface, forces were gathering that would soon reshape the world. Massive volcanic eruptions began to poison the air and darken the skies, setting the stage for disaster. A catastrophe was brewing, one so immense that it would dwarf even the asteroid impact that would later end the reign of the dinosaurs. The greatest test of survival in Earth's history was about to begin, threatening to erase the land of giants and forever alter the course of life on our planet. 252 million years ago, as the Permian period gave way to the Triassic, Earth teetered on the brink of total annihilation. The world was unrecognizable. Vast supercontinents stretched across the globe, their interiors parched and windswept, while ancient seas lapped at barren shores under a sky heavy with foreboding. This was the time of the Great Dying, the most catastrophic extinction event in Earth's history. In the blink of a geological eye, the intricate web of life that had flourished for hundreds of millions of years was torn apart. The devastation was nearly absolute. The land became a graveyard of silence, the air thick with ash and the stench of decay. The very fabric of the biosphere unraveled, threatening to erase all complex life. The scale of loss defies comprehension. Up to 96% of marine species vanished, along with 70% of vertebrates on land. Coral reefs, once teeming with life, dissolved into lifeless rubble. Forests collapsed, leaving only skeletal remains. The lush, ancient forests that had dominated the Permian landscape withered and died, their canopies falling in slow motion, their roots exposed to the searing sun. Swamps and wetlands dried to dust, and the chorus of amphibians and insects faded into silence. The apocalypse was triggered not by a cosmic impact, but by the planet's own restless interior. Deep beneath the crust, titanic forces built up until the land itself ruptured in a cataclysm of fire and stone. In what is now Siberia, a vast region split open, unleashing a relentless barrage of volcanic eruptions. For hundreds of thousands of years, the Siberian traps poured forth lava, covering millions of square kilometers in basalt. These were not ordinary volcanoes, but immense fissures that bled molten rock and toxic gases into the atmosphere, transforming the landscape into a hellscape of fire and stone. For nearly 1 million years, these eruptions belched out unfathomable quantities of carbon dioxide, methane, and sulfur compounds, shrouding the planet in a toxic haze and driving the climate into chaos. The greenhouse effect spiraled out of control. Global temperatures soared by as much as 10 degrees Celsius, melting polar ice and turning once fertile plains into deserts of cracked, sun-baked earth. The consequences were swift and merciless. Forests burned and withered, their remains scattered by relentless winds. The land became a wasteland, stripped of shelter and sustenance. On land, the heat and drought drove ecosystems to collapse. Deserts expanded, swallowing the last remnants of green, while rivers and lakes evaporated into memory. In the oceans, the devastation was even more profound. Once vibrant reefs and kelp forests became graveyards, their inhabitants gone, their colors faded to gray. As the seas warmed, oxygen levels plummeted. Vast stretches of ocean became dead zones, suffocating marine life and leaving only the hardiest microbes to endure. The relentless influx of carbon dioxide made the oceans dangerously acidic. Shells and skeletons of marine creatures dissolved, erasing entire lineages from the fossil record. In the final act of this planetary crisis, oxygen-starved bacteria flourished, releasing torrents of poisonous hydrogen sulfide. This toxic gas seeped from the oceans, poisoning the air and further darkening the skies. Life was besieged from every direction, scorched by heat, suffocated by lack of oxygen, corroded by acid, and poisoned by gas. The world became a crucible, testing the very limits of survival. Against all odds, a handful of species endured. In isolated refuges, deep burrows, shaded crevices, and the last cool streams, life clung on, battered but unbroken. The aftermath was a world stripped to its barest essentials. Only the most adaptable and resilient organisms survived, tough plants, burrowing invertebrates, and a few hardy vertebrates. Recovery was agonizingly slow. For millions of years, the land remained a shadow of its former self, but gradually life began to reclaim the wastelands. Green returned inch by inch as new ecosystems took root. From the ashes, the first pioneers emerged, ferns, mosses, and simple plants, followed by the slow return of animals. Each sunrise brought new hope to a world reborn. The extinction of the dominant synapsids opened the door for a new lineage of reptiles. In the silence left by the Great Dying, these survivors evolved and diversified, setting the stage for the rise of the dinosaurs and the dawn of a new era on Earth. The saga of Earth's mass extinctions is etched into the very crust of our planet. Each impact crater, each fossil layer, a silent testament to the relentless forces that have shaped our world. These scars remind us that the planet's history is not one of gentle continuity, but of sudden, violent upheaval and fragile recovery. Today, as we orbit the Sun, Earth remains exposed to the same cosmic hazards that once ended entire eras of life. The threat from space is ever present. Asteroids and comets, remnants from the solar system's formation, continue to sweep through the void, their paths sometimes intersecting with our own. Our solar system is a dynamic, ever-changing arena. Swarms of rocky and icy bodies drift silently, their courses altered by gravitational tugs and ancient collisions. Earth's journey through this cosmic shooting gallery is a constant, silent gamble. Modern science has revealed that impacts are not a matter of speculation, but of statistical certainty. The question is not if, but when, a significant object will cross our path again. Every year, Earth's atmosphere intercepts thousands of tons of cosmic debris. Most of it is vaporized in brilliant flashes high above the surface, leaving only fleeting traces in the sky. Yet, on rare occasions, a larger object survives its fiery descent. In 2013, a 20-meter-wide asteroid exploded over Chelyabinsk, releasing energy equivalent to a nuclear blast and shattering windows across a vast region, an event captured by satellites and sensors worldwide. Unlike the creatures of past extinctions, we are no longer passive witnesses. Our vigilance is now woven into a global network of observation and analysis, tirelessly monitoring the heavens for signs of danger. We have become the sentinels of our own fate, scanning the cosmos with ever-increasing precision, searching for the faint signatures of objects that could threaten our world. Space agencies and research institutions have established sophisticated programs to detect, track, and characterize near-Earth objects, NEOs, using a combination of optical, infrared, and radar technologies. With powerful instruments, we catalog thousands of asteroids, calculating their trajectories with mathematical precision and assessing their potential to intersect with Earth's orbit in the future. To date, over 30,000 near-Earth objects have been identified, including more than 1,000 that are over a kilometer wide, each one large enough to unleash devastation on a planetary scale. This planetary census forms our first line of defense. By knowing what is out there and where it is headed, we gain the crucial advantage of time to prepare, to act, and to avert disaster. But what if our calculations reveal an object on a collision course with Earth? The stakes could not be higher. For the first time in the planet's history, a species possesses the knowledge and technology to intervene, to alter the course of a cosmic threat. We are developing and testing strategies for planetary defense, from kinetic impactors to gravity tractors, each designed to gently shift an asteroid's path without fragmenting it. The objective is not destruction, but precision, using the subtle force of a spacecraft's impact or gravitational pull to nudge a hazardous object just enough to miss our planet entirely. Recent missions have proven that a high-speed spacecraft can successfully alter an asteroid's orbit, transforming science fiction into a practical tool for planetary protection. Yet, all of these technologies depend on our most precious resource, time. The earlier a threat is detected, the greater our chances of success. To mount an effective defense, we require years, ideally decades, of advance warning, allowing for careful planning and execution. The greatest challenge remains our observational blind spot, asteroids approaching from the direction of the Sun, hidden in its glare until they are dangerously close. These stealthy threats test the limits of our detection systems. Even so, advances in technology, such as space-based infrared observatories, are expanding our reach, allowing us to peer into regions once lost to the brilliance of the Sun. The history of life on Earth is a chronicle of resilience, of species rising from the ashes of catastrophe, ecosystems rebuilding in the wake of devastation, and diversity flourishing anew. From the Permian extinction to the asteroid that ended the reign of the dinosaurs, life has endured, adapted, and persisted against overwhelming odds. Now, as stewards of a 4-billion-year legacy, we wield the tools of science and technology to safeguard our planet. Our modern vigil is a testament to human ingenuity, a promise that, armed with knowledge and vigilance, we will stand ready to meet the next great test from the sky. Beneath the continents and oceans, Earth's crust conceals a hidden archive, a record not only of catastrophic impacts but of another relentless force that has shaped the fate of life, the deep, restless heart of the planet itself. Long after the last asteroid fragments settled and the skies cleared, mass extinctions continued to be written by forces rising from below. Across millions of years, colossal volcanic provinces, known as large igneous provinces, have erupted with unimaginable ferocity. These eruptions, spanning hundreds of thousands of square kilometers, blanketed the land in rivers of lava and filled the atmosphere with choking gases. From the Siberian traps to the Deccan traps, these titanic outpourings rewrote the rules of survival. Their legacy is visible in vast basalt plateaus and the chemical fingerprints left in ancient rocks. As magma surged upward, It unleashed pulses of carbon dioxide and sulfur compounds, shrouding the planet in toxic haze. Global temperatures soared, then plummeted, as sunlight was blotted out and acid rain scoured ecosystems. In the oceans, the delicate balance of chemistry faltered. Acidification dissolved the shells of plankton and corals, unraveling food webs from the bottom up. Anoxic waters, devoid of oxygen, spread across the seafloor, extinguishing entire lineages in silent darkness. These volcanic cataclysms were not isolated episodes, but part of a deeper cycle, one driven by the slow drift of tectonic plates and the inexorable churn of Earth's mantle. From the margins of supercontinents to the rift valleys of ancient seas, the planet's interior has been both creator and destroyer, forging new habitats even as it erased the old. Yet, within the devastation, life's resilience endured. In the aftermath, survivors crept back into barren landscapes, adapting to new climates and forging unexpected paths. The scars of these upheavals remain etched in the crust, vast lava fields, buried ash layers, and the chemical traces of lost worlds. Today, the deep engine of our planet still pulses, quietly shaping continents and climate. The lessons of past volcanic extinctions lie buried beneath our feet, a silent warning and a testament to the restless power beneath the surface, a reminder that Earth's greatest threats sometimes rise not from the heavens, but from within. In the vast, primeval oceans of Earth's distant past, a different kind of catastrophe unfolded, one not of fire or stone, but of invisible chemistry. This was the Great Oxygenation Event, a silent siege that forever altered the course of life. Over 2 billion years ago, the world was ruled by single-celled organisms, thriving in an atmosphere almost devoid of oxygen. But deep within shallow seas, ancient cyanobacteria began a quiet revolution. Harnessing sunlight, they released a waste product unknown to the world: oxygen. At first, this new gas was absorbed by iron dissolved in the oceans, painting the seafloor in bands of red iron oxide. But as the supply of iron was exhausted, oxygen began to leak into the atmosphere. For much of life, this was poison. Microbes that had flourished in a world without oxygen faced extinction as their biochemistry faltered. Across the planet, entire ecosystems collapsed, unable to adapt to the new, hostile air. The skies themselves transformed as methane, a greenhouse gas, reacted with the rising oxygen, plunging the Earth into a deep freeze known as the Huronian glaciation. Ice advanced toward the equator, and for millions of years the planet lay locked in a global winter. Yet in the shadows of extinction, life endured. Some organisms retreated to oxygen-free refuges, deep within sediments or in the anoxic depths of the sea. Others evolved new biochemical pathways, turning the deadly gas into a source of power. In time, the survivors emerged, more complex and energetic than before. The oxygen that once threatened life became the fuel for evolution's next leap, paving the way for multicellular organisms and ultimately the rich tapestry of life that would follow. The echoes of this ancient crisis endure in the rocks and in the chemistry of every breath. The Great Oxygenation Event was not only an extinction, but a transformation, a silent siege that forced life to adapt, innovate, and ultimately to thrive in a world forever changed. Beneath the ancient crust of Earth, another threat simmered, one neither alive nor truly dead, but capable of reshaping the destiny of everything above. This was the age of the supervolcano. Millions of years after the world's first oxygenated breath, the planet's restless core stirred. In hidden chambers, pressure mounted, magma pooled, and for eons the surface world remained oblivious. But sometimes the balance tipped. A supervolcano does not erupt like ordinary volcanoes. Instead, it unleashes a fury on a scale almost unimaginable. In a matter of hours, entire mountain ranges vanish, replaced by calderas dozens of miles wide. Ash clouds billow into the stratosphere, blotting out the sun and spreading a veil across continents. The land beneath becomes a wasteland. Forests collapse under the weight of falling ash. Rivers turn to mud, and lakes vanish beneath choking debris. The sun's warmth is stolen away. plunging the world into volcanic winter. Temperatures plummet, photosynthesis stalls. For many forms of life, it is a sudden, suffocating end. Yet, in these darkest days, the struggle for survival continues. Deep in the ocean, hydrothermal vents pulse with warmth and nutrients, offering sanctuary to resilient bacteria and tube worms. In ash-choked lakes, hardy algae adapt to the dim light filtering through the haze. Burrowing creatures, insulated by earth and instinct, weather the famine above. Slowly, over decades, the skies begin to clear. Life, battered but unbroken, emerges from the shadows. The great extinction leaves space for renewal, for new species, new adaptations, and new possibilities. The silent shadow of the supervolcano, though devastating, becomes another forge for evolution, shaping the diversity and resilience of life on Earth. Even today, the scars of ancient eruptions are etched into the land, and somewhere deep below, the next chapter of survival waits to be written, reminding us that the greatest threats are often those that lie hidden, patient, and silent beneath our feet. In the eons following the wrath of the supervolcano, Earth's story was far from tranquil. Deep within the ancient oceans, another crisis brewed, one invisible, insidious, and devastating. This was the age of the toxic seas. For millions of years, the balance of life in the oceans had been delicate. Tiny plankton and algae, fed by sunlight and nutrients, formed the foundation of the marine food web. But when ancient climates warmed and continents shifted, vast amounts of nutrients flooded into the seas. The result was a silent explosion, not of fire or ash, but of microscopic life. Algal blooms, fed by this bounty, spread for thousands of miles. At first, the oceans teemed with color and energy, but as the blooms died, their remains drifted to the depths, feeding swarms of bacteria. These bacteria consumed not just the dead algae, but the very oxygen in the water, leaving vast regions of the oceans anoxic, devoid of life-sustaining air. As the oxygen vanished, toxic gases, hydrogen sulfide and methane, began to seep from the depths. Fish, mollusks, and ancient sea reptiles suffocated in these poisoned waters. Coral reefs, once vibrant citadels of life, crumbled into lifeless wastelands. Even the skies above were not immune. Deadly gases drifted into the atmosphere, casting a pall over land and sea alike, and triggering yet another wave of extinction. Yet even in this hostile world, survivors emerged. On the seafloor, hardy worms and crustaceans adapted to life in the dark, oxygen-starved mud. Microbes evolved to feed on the very toxins that killed others, forging new and bizarre forms of life. In isolated pockets, where currents still brought fresh, oxygen-rich water, ancient lineages clung to existence, waiting for the seas to heal. As the ages passed, the oceans slowly recovered. The toxic tides receded, and new species rose to fill the void. The scars of this hidden catastrophe remain etched in ocean sediments, a silent testament to the fragility and resilience of life. The story of the toxic seas reminds us, extinction does not always roar. Sometimes it whispers, carried by silent waves beneath the surface, shaping the world in ways unseen. Beneath the recovering oceans and the churning skies, another chapter unfolded, one written not in flesh or bone, but in stone and crystal. After the toxic tides receded, Earth's surface entered a strange and silent era, where minerals took center stage and the land itself became an engine of transformation. It was an age marked by relentless chemical change. Ancient mountain chains, battered by wind and rain, shed their minerals into rivers and valleys. These torrents carried a wealth of elements, iron, copper, sulfur, spreading them across the continents in shimmering veins. In vast salt flats and desolate basins, water slowly evaporated, leaving behind carpets of gleaming crystals, halite, gypsum, and rare metals that sparkled in the sun. But this mineral bounty came at a cost. In some regions, chemical reactions between rainwater and exposed rocks unleashed sudden waves of acid. Streams turned milky white, then blood red, as metals leached from the earth and poisoned the land. Forests, already struggling in the aftermath of extinction, withered and died, leaving behind fields of petrified wood and twisted mineral formations, nature's sculptures, frozen in time. Beneath the surface, life adapted in unexpected ways. Microbes colonized glittering mineral caves, feeding on iron and sulfur, painting the walls with vivid oranges and deep blues. Some formed strange, branching colonies, living stalactites that dripped from cave ceilings, glowing faintly in the darkness. These were the architects of a new world, carving out niches where almost nothing else could survive. Above ground, mineral crystals grew unchecked, transforming landscapes into alien vistas. Towering spires of selenite reflected the dawn, and lakes crusted with borax shone like mirrors. For a moment in Earth's deep history, the land itself became the protagonist, a canvas for the endless dance of chemistry and time. Eventually, the mineral cataclysm faded. Rain softened, soil stabilized, and new life returned to reclaim the altered Earth. Yet the legacy of this crystal age remains: hidden geodes, veins of silver, and the brilliant colors of oxidized stone. These are the silent witnesses to a forgotten chapter, when minerals ruled the land, and Earth itself became both destroyer and creator.